In this video, I'll explain how to take a logical form and generate instances of that, propositions that are instances of that form. I'll also explain what the relationship is between an instance and its form. In the last video, we learned how to take a proposition and determine every logical form that it's an instance of, and how to use well-formed formula variables to stand for those different spots in those logical forms. So now we're in a bit of a better position to give an idea of exactly what we mean by logical form. And our author, Nicholas Smith, gives as the example alpha or beta. That's the example of a logical form. But what makes it a logical form? Well, he also gives 3 criteria here. First, that it must be a well-formed formula. So for example, or beta cannot be a logical form because it's not a well-formed formula. It doesn't follow the rules that we determined earlier on in this course as to what would constitute a sentence in propositional logic in this language that we've created. The second criterion is that it must have at least one well-formed formula variable. So for example, A or B can't be an argument form because it doesn't have any well-formed formula variables, even though it is a well-formed formula itself. And then our third criterion is that it can't have any basic proposition. So for example, A or beta, that doesn't count as a logical form because it has a basic proposition in it. Now you may wonder, this is kind of an odd collection of criteria here. Why is this constitute a logical form? Well, the first thing is that third criterion there. Remember that we don't want any basic propositions because basic propositions have content. They stand for a specific proposition, but we want to say that this is a logical form with no specific content. We've abstracted from the content, right? We have placeholders like these well-formed formula variables for where the content could go, but we don't want to say this specific content. We want to leave that part open and just look at the structure. So that's why the third criterion is there. The reason we have criterion 2 in there is to make sure that we are making those placeholders. We're using these well-formed formula variables as placeholders for things that have content, but we don't have content itself. And of course, the criterion 1 is because if we don't have a well-formed formula, then that's just not what our structure, we're missing part of our structure. But notice an important thing that's omitted here. He doesn't say that we have to replace the basic propositions with well-formed formula variables. Why not? Well, because remember, we don't necessarily have to replace them at that level, at the level of basic propositions. So I could replace A or B with alpha or beta, but I could go one level up and just replace A or B entirely, that entire well-formed formula with the well-formed formula variable alpha. And doing these 2 different things, replacing them at the alpha or beta and then replacing them at the higher level of just alpha, will generate 2 different logical forms, and A or B, remember we said, will be an instance of both of those forms. So now that we know what logical forms are, how do we make instances of logical forms? What does all that mean? Well, let's take the example that our author gives us here in form 5.1. It's not the case that if alpha, then alpha or beta. So that's our logical form. It has well-formed formula variables. It has no basic propositions. It is a well-formed formula itself. Logical form here. How do we take this logical form and generate different propositions from it? Well, the easiest way is to just replace the well-formed formula variables with basic propositions. So it's not the case that if A, then A or B. It's not the case that if C, then C or D, etc., etc. Now remember, we said in the last video, our reminder 1 was that our well-formed formula variables can be replaced by a well-formed formula of any size, right? Could be a basic proposition or it could be a compound proposition. So instead of replacing the alpha with A, I could replace it with A and C, and then I would have, it's not the case that if A and C, then A and C or B. And then remember that reminder 2A was that different well-formed formula variables can be replaced by the same well-formed formula. So for example, I could replace alpha and beta with just A, and I can have, it's not the case that if A, then A or A. And now we'll throw in a new thing here, reminder 2B. And this is a rule that he gives in the chapter, which is you can't take the same well-formed formula variable and replace it with different well-formed formulas. So I can't take the alpha and replace it with an A in one spot and a Z in another spot. I can't say, it's not the case that if A, then Z or B. And if you'd like to, again, like I said in the last video, you could sort of think of this, it's similar to the way we replace variables in algebra. So I can take an x plus y and I can replace both of those with a 3. I could say 3 plus 3. That's okay. You're allowed to do that. What you can't do is take x plus y and replace the x with a 3 in one spot and a different x with a 4. So you can't have 3 plus 4 plus 5, for example. That doesn't count. Whenever you have an x, you have to replace it with the same number, the same value. Same thing here. Whenever we have a well-formed formula variable, we replace it with the same well-formed formula consistently throughout our new proposition that we're generating here. Now, a little bit of important terminology before we move on here to the exercises. We're going to use the word instances of specifically to talk about logical forms and the propositions that are instances of those logical forms. So for example, proposition A or B is an instance of the logical form alpha or beta. Also, the proposition C or D and E, that's also an instance of this logical form, right? It's an instance of the form alpha or beta where C is where alpha is and D and E is where beta is. Now, when we say that we have these two propositions and they're both instances of the same form, what we're going to say is that they share the same form. We won't say they are both of the same form. Why not? Well, notice that this second proposition here also is an instance of a different logical form, alpha or beta and gamma, whereas our first proposition A or B is not an instance of that form. So even though they might share one logical form, they don't necessarily share them all. There are propositions that do share the same exact logical forms throughout, but there are also ones that don't. So we're going to use this specific terminology. They share the same form. So let's go ahead and get started with 5.2.1 exercises. And our first problem says that these three propositions all share three of the same logical form. They're all instances of three logical forms. So which ones are those? Well, the first one is that, and this is for any proposition. Any proposition, you could take a well-formed formula variable and replace the entire proposition with it. So the form one here is just alpha, where alpha could stand for not C, alpha could stand for not A and B, and then finally alpha could stand for not C and not D. But it's also the case that we can take, not just the entire proposition, but most of the propositions, just not that first negation there. So we'll have a negation and then alpha. That is our second form here, not alpha. And not alpha, alpha could stand here for not C. It wouldn't stand for not C, right? Just the not C, because in this logical form, right, we already have a negation there. The alpha could stand for not A and B, and alpha could stand for not C and not D. And then finally, we can have the form of not alpha, right? They all three of these guys have a double negation and then some proposition. And the proposition in there isn't necessarily the same, but it's some proposition there. So alpha can stand for C, alpha can stand for A and B, alpha can stand for C and not D. Problem 2 here gives us logical forms and asks us whether the propositions below them are instances of that logical form. So our first logical form here is not the case that if alpha then beta, and our first proposition here is it's not the case that if P then Q. And sure enough, this is an instance of that logical form where P replaces alpha and Q replaces beta. And then our second one is it's not the case that if R then Q. And notice the only difference here is between there used to be a P there and now that there's an R there. So yeah, this is also an instance of the same logical form where R replaced alpha and Q replaced beta. Then we have it's not the case that if R then Q. And this also is an instance of that logical form where we have R replacing alpha and if R then Q replacing beta. Then our second logical form here, it's not the case that if alpha then beta. And our first contestant is it's not the case that if P then Q. And that is indeed an instance of that logical form where we have P replacing alpha and Q replacing beta. Our second possibility here is it's not the case that if P then P. And interestingly enough, sure enough, this one is also an instance of that logical form where we have P replacing alpha and P replacing beta. Remember, according to reminder 2a we had, you're allowed to do that. And then our third possibility here, it's not the case that if P, then if Q, then P. Now, we do have a problem here. And the problem is this, that we have P replacing alpha and also Q replacing alpha. And according to our reminder 2b, you're not allowed to do that. Now, P is replacing beta. That's okay. You're allowed to have like P replacing alpha and P also replacing beta. But it's that Q that's the problem, right? You're not allowed to have two different well-formed formulas replacing the same well-formed formula variable. Problem number 3, if alpha or beta, then alpha and beta. And our first possibility here, if not P or Q, then not P and Q. And this is an instance where not P is replacing alpha and Q is replacing beta. Then we have if P or not P, then P and not P. And this also is an instance where P is replacing alpha and not P is replacing beta. And then we have if it's not the case that R or S, then it's not the case that R and S. This is not an instance. And the problem here is those two negation signs, right? Even though everything else lines up, we throw those negations in there. Unfortunately, that's a different logical form. Our fourth logical form, alpha or not beta or alpha. And our first possibility, P or Q or Q or P or Q, and this is not an instance of that logical form. The alpha is fine, right? The alpha was replaced in both places by a P or Q. The problem is the beta has a not in front of it in our logical form, and yet we don't have a not in front of that Q. So not the same logical form. Now, interestingly, Q is actually identical to not Q. So if we had not Q, then we could have that first negation and then beta could be replaced by that not Q, and then we would be good, only that's not what our proposition says here. Even though they're logically identical, that's not what our statement says here. Our second one is Q or not Q or Q and Q. Now, again, Q and Q is actually identical to just Q, but that's not what this proposition says here, right? So we have alpha being replaced by Q in one spot and by Q and Q in another spot. So those are two different propositions. So this isn't an instance of a logical form. The beta is fine though. And finally, we have not P or not P or not P. And this is an instance where alpha is replaced by not P. Beta is also replaced by not P. So yeah, replaced by the same well-formed formula, that's okay, we're allowed to do that. For next time, please go ahead and read 5.3 and do 5.3.1 exercises, and I'll see you in that video.